It's great to be here. It's also my fifth GDevCon, but the first one here. I'm going to start with our giants are female, and I want to highlight Margaret Ingalls. She lived a century ago. I was the first female to graduate at University of Kentucky. And she joined the American Society of Heating and Ventilation Engineers Research Lab, and I'm currently also working in HVAC. That's why I wanted to highlight her. And also because she was very involved in the effective temperature scale. I learned that heating and cooling is more than temperature. It's about human comfort, and you have to take humidity and airflow into account, and she played a big role in that equation. She was also a speaker, well-known speaker, an inspiration to a lot of women in engineering. And one of her famous speeches is Petticoats and Slide Rules, where she states that they're not incompatible, which was a big deal in that time. Now, my presentation, there's a long title on your agenda, but it could have been a tree full of object data. Now, the agenda, a little bit about me. I'll start with a warning, describe the problem statement, the solution, some use cases, and I hope to have time for a bonus, a small gift. So it's about trees and gifts, but it's the wrong season right now. And then at the end of the presentation, there are a couple of slides with all the links for stuff that I used, because I'm mostly connecting dots from other people and using a lot of packages. Well, about me, I work at Yaga Climate Designers. Use LabVIEW since also previous century, LabVIEW 5 that was. I'm a pretty recent LabVIEW champion. Member from the start of Sam's mastermind group. I created a leaderboard for the Advent of Code. So if it's the right season, then you can join the Advent of Code challenges and join our Discord server, have some fun there. I also once did a presentation on LabVIEW shortcuts, and there is a booklet with this link. You can download the PDF and get a lot of shortcuts, quick drop shortcuts, native shortcuts. I mostly use Active Framework. That will also pop up in this presentation occasionally. And on the forums, there's a tutorial from going from basics to using PPLs as plugins in Active Framework. There are my handles at the bottom. So if you have a question, reach out. Now about my employer, Yaga. We call ourselves climate designers because we take care of your indoor climate, but also without damaging the outdoor climate, which is important to us. We have 5 big values that we try to work around, which is respect nature, probably the most main value. Awake the artist. We want to create beautiful stuff. If people like it, or if people find it beautiful, less they throw it away, and it's more, it's better for the environment. Dream a future. We try to be innovative. We want to create emotion. If people like the product, they want to keep it. And build bridges. Some of our bigger projects are buildings over there, which is Google and a big office center in Vancouver. An example of our products, radiators that can heat and cool. There's a lot of electronics in there, and I do the testing for that. Now the warning. First of all, this works for me. I'm an R&D test engineer, mostly use the applications myself, and a few other people. But they can be more foolproof. I'm not saying I'm not a fool, but I'm the fool that the developer, me, expects. There is room for improvement, so more foolproof or better performance maybe. And the biggest warning of all, this will break encapsulation. Along the way, you will see we will break encapsulation. I'm not a big fan of breaking it, but it was convenient here. So maybe, I hope you all have some takeaways from this presentation, but don't let it be this one. Use it very carefully. And we don't just break stuff, we do it for a reason. Now, my problem statement. I started at Yaga 1.5 years ago, had carte blanche, created a lot of new applications. That's also a lot of new configuration screens. And that wasn't very appealing, like, yeah, another configuration screen, add another parameter to the screen. So here are some examples of configuration screens. For example, the configuration editor framework or the options dialog framework. But for every screen, you need to create a UI. You have to add all the controls in there. If you change something, you have to update the screen. So I was tired of doing that. And I saw a challenge. I want to make something generic that was more appealing. So my requirements, a generic UI to do this. It must be user-friendly, but most of the time I'm the user, so friendly to me. I want to take a configuration object, display it, edit it, read it from file, save it to file. So let's get back. These are two things, display edit and the file stuff. So now my solution is split it into two parts. And as I was going over this presentation on the plane yesterday, it occurred to me that in the past, I took this object and saved it to file or restored it from file, and then the settings screen displayed the object state. What I'm doing now is the file is in the center. So the object is stored to file, but the screen has nothing to do anymore with the object. It's just showing data from my configuration file. Now, which file format? I've used a lot of XML in the past, and I was a bit stuck to that in my previous job, and I wanted to switch to JSON. Why? I think it's a bit easier to read. It has better support on certain elements. Also, optional elements are easier in JSON. And it's just a way to represent objects. It's JSON, it's JavaScript object notation. And it was also already used in our device controllers at Yaga. I can do requests and get status or set configuration through JSON. So let's go for JSON data. Nope, the other way. Whenever I think of JSON in LabVIEW, I think of Dr. James Powell. He has great toolkits, and the JSON text makes it very easy to convert data types to JSON, to use the JSON path notation to get elements out of a big JSON data structure. And pretty recently, it also supports scheme validation, which is important because whenever I enter something in my generic UI, I can validate it now. But it doesn't support objects. And I wanted to do objects because I wanted to take the advantage of inheritance. Now, luckily, Dr. James Powell had foreseen a way to create plugins for his toolkit. And another guy called PNR, is Pascal Neuperger from Germany, created an object serialization toolkit. This is an extension to serialize and deserialize objects to JSON. It's very easy to use because all you have to do is here on screen. On the left side, take your object, like you did in the past, use the JSON text sub-VI, but with a serialization class attached to it. Or the other way around, also deserialize the JSON. This example shows a great, there, if you can read it, it's a link to test GCentral, where you can get a list in JSON of all the GCentral packages. And that was one of the examples that I tested with. But you already see it here. We're going to break encapsulation because we're going to take our objects, private data, store it in text, and then it's accessible to everybody. So we broke encapsulation. And that's done inside that serialization class plugin with another toolkit from Pascal Neuperger. It's LabVIEW composition. It composes and decomposes objects into an array of variant data. And the top level is the private data of the ancestor, and the latest element in the array, the last element, is the private data of your current actor. This toolkit works for objects, but regular clusters, but that you can do already with the normal JSON text toolkit. Also works on maps and sets, but I haven't used it for that. This is what breaks your encapsulation. It makes the private data easily accessible. It's also very easy to use. Now, here, we know how to convert our data, object data, into JSON text. So, okay, we can store it to file, read it, deserialize it, or restore our object back. So that's actually part one. Now, how are we going to display that JSON? I was looking for a generic way to display. I don't want specific controls for each data type. And it occurred to me that trees are very generic there. They can handle data with multiple levels, different data types, because you just show the strings. And they're also commonly used on the internet if you want to display JSON. You can display it in text, but also in tree structures. So choosing a tree had nothing to do with being a climate designer or with the advent of code trees. It was the convenient way here. Now, show JSON in a tree. I thought, let's ask ChatGPT, but it was either my English or I still have to learn, like Eric said, how to use that generative AI, but show JSON in a tree came up with this. So, no. Luckily, I don't have to rely on ChatGPT. There are LabVIEW friends that help us. And one of the gifts, or a little present we got, came from Steve Watts. He wrote a blog post in 2016 already. Tree control, a little present on his random ramblings, which showed in detailed steps how to go from a database table and populate a tree. A database table, which means you need a column with IDs and a column with, which is your parent, and then you have a linked structure, and you can populate your tree. Or as Steve calls it, add another leaf to the tree. But I don't have a database table. I have JSON data, which is well structured, but I don't have this information. And then I remembered a presentation from, again, Dr. James Powell at GDevCon number 2 in Birmingham. How to convert your JSON into a database table. And the real trick here is to use JSON text and SQLite, also a package of Dr. James Powell. I really recommend this YouTube recording, and as he says it, it's very easy to use. It's less rigid because you store your JSON data in your database table, which now only has one column. If your data type changes, you don't have to change anything on your database. It's there. You don't have to insert a lot of columns in your database. So it's less rigid. And SQLite natively supports JSON functions. I'll show a few of them here. It's also searchable. It's very fast. Even tells there that you can filter like 2 gigabytes of data in no time. So I want to go through a couple of examples. The data that I used is something that I just grabbed from the internet about actors, but not the real actors that we're talking about in LabVIEW, the ones that are pretending something to do in Hollywood. So it's a database, an array of actors with name, age, different parameters, another one. So that's the example data that I'm going to use here. The first and most important function in SQLite when you're using JSON is JSON tree. It queries your JSON. It returns a table, like shown here, with a key and an ID. Here's the ID and the parent. So we got our data table that we can populate our tree with. And all you have to do is open an in-memory, because it's an empty string, it's just an in-memory database, and add this. So select everything from your JSON tree. This is your entire JSON string, and you get the table. You can do less than that if you only want the ID and the parent, but as an example here. Most important about JSON tree is that it walks recursively through the substructures. So you get the entire tree. And I must say, if you have a lot of data and the JSON string is very big, it's better to pre-populate that in-memory or on-disk database and then do the querying. A little bit like JSON tree is JSON each, but that only walks one level. So you can tell it which level you want. For example, get all the elements from an array. And then you get every element, but you don't get the sub-elements if there are clusters in an array. You just get all the cluster data. Or if you have a big cluster with a couple of clusters in them and you want only top levels, It's easy to, this will also get all the top elements. But if you want sub-elements, you can ask for specific. So if you only want like the children array, you have to add comma and then $.children. There will be an example later. Now, JSON extract returns a value. And sounds a bit silly because it's like unbundle cluster or use the find item in JSON text. So I'm never using JSON extract to extract data, but I'm using it to filter data. I add it to a query, and then suddenly I get each, my entire JSON string, all the actor data, extract the age value, and filter the ones above 55. And then I can have a big array of data and do a very quick filter just by composing some SQLite queries. Another thing that I noticed is it's easy to add empty elements. My user interface doesn't know my data types in the object. And still I can say add an element to the array by adding a null if it's a regular data type. But that gave me this error on clusters. So there I had to add curly brackets, empty curly brackets. So this, in my JSON, there's an empty element, and when the deserializer puts it in the object, it's a default element. It decouples the user interface from the object. Now, the first use case is just a viewer. I can show you the viewer. It's here. I can run it. I get, yeah. Just loading a test class. Create a new, add an element. It should add an element. I'm going to read from this one. Yeah. So here, it read from file. It was a JSON file with all this data in it. And now, can you guys see this, or I can zoom in? No. That one. It's a small tool. Come on. No. The zooming is not working on there. So here it says $.actors, so it will get all the actors if I do a JSON each. And filter on the age above 50. I'm going to apply the above, let's say, 55. I'm going to apply the filter, and then we'll only see the one above 55. It's a simple example, but on a large data set, it's very powerful. And here, my second use case, because I realized I can also do my result screens with this. If I have a data result, my air temperature, I got a measured value, I store the limits at the time it was recorded, status, whether this test was passed or failed. Now, I can use the air temperature and all the above elements to create my tree, and all the sub-elements to add additional columns, or even color a row by the status. So that way I can also log my results in JSON, either JSON files or a big SQLite database with a row for each measurement containing just one element, a JSON string. And if I change something, not much happens, because if I add an element to the measurement, the next entry in the database will have that extra element, but I can still filter on all previous things if I want to compare air temperatures. Now, the actual use case that I was looking for, my configuration UI. So now, my configuration file is a JSON file with a section for each actor. And now I'm again talking about the actors that we know in LabVIEW. These are the sections. So with the JSON each, I return the top elements of the JSON file, and I know all the actors that are defined there. This list, I select one actor, get the sub-element, and show it there. In a very generic way, I can edit stuff here, and with scheme validation, if somebody enters an invalid number, I ignore it. Just go back. And this makes it powerful for actors, because now I don't use INI files anymore. I use JSON files for configuration with a section for each actor. And if I change or add data, configuration data to that actor, don't have to change the screen. It will be in that tree. It will be there with the default value to start with. I can edit it. And it's a lot of tedious work I can skip now. Now, on actors, I'm using a base actor because I'm also using the message forwarding tool from Zaya Solutions. That takes care of all the message forwarding. But since it was there, I added this reading and writing to the configuration file in my pre-launch init. So every time an actor gets launched, it gets a bit more technical on actors, but this is the current actor. We get the class name. So currently, it's only it has a section per actor class. If I launch clones, they use the same configuration, but I can solve that by using aliases and storing it in the actor's private data. Then I should use the alias instead of the class name, but for now, this works. I'm using the decompose LabVIEW object, get the last element. That's the private data of my current actor. If there's a configuration cluster in there, I'm going to read the file. I'll go to in the next slide. Get my variant data here, add it back to that array, decompose the object, and we're good to go. And this works for all my new actors without having to add a way to read and write their specific configuration data every time again. Now, let's go into this read config file. So we have a cluster data type here. We have a name from the actor. This is just the path from the file. And we want to get our data out. This case says JSON. The other case says INI, but I'm not using much INI files anymore. The INI case uses the OpenG read section cluster. So my section is root, actor name, just read the JSON file, find the element, and this gets the JSON from the file, but just a subsection of this actor. And then I was struggling a bit because I wanted to turn that JSON into this variant that I could add to the array and good to go. But the JSON text VIs were bad at keeping the data types. So I had to use JKI's serialization, which very well keeps the data types. And then I'm good to go. So combining these two toolkits finally got me there. And now if I create a new actor, I just add a private data, a cluster called config. If it's there, it will be in the ini file, in the JSON configuration file. If it's not there, no problem. Changing or adding parameters, no problem. So generic way of working saves me a lot of adding this every time. Now, a bit ahead of schedule, but OK. There's a bonus. Suppose you get JSON strings, or even, I'm going to show you, the one that's on the gcentral. It describes packages, and it can be a very long string. So if you get this and you need to use it in LabVIEW as data, in the past I created those clusters and was prone to errors, or I had to change something. Or they are very big and you're busy a long time. Oh, let's do this. Now, create the data type, or even create the data type with all the data that's in the example. Let me show you an example here. It's a small tool I created to help myself. And so we're talking about gifts and trees. This is a gift that I'm going to put on the Discord later on. So I can run the tool, read a JSON file, or just paste the JSON data here. I can select to convert it with data or without data. Let's do without. Convert. And now it's on the wrong screen, but here's the data type. So makes it very easy to get your JSON, have a data type in LabVIEW, get it started. It's even easier to create new data types in LabVIEW by writing the JSON first, because you just type in what you want, create your LabVIEW type def. It creates clusters, not objects, but just put them in the private data of the object, and you're good to go. Be careful on how you define things. ID is an integer, so it's a number. Shouldn't be in between quotes. Name is a string, should be in between quotes. If you define a Boolean, like here. It has to be true or false. Some JSON schemes say bool or Boolean. So if it's the correct definition here, then it will give you a big data type. Yeah. So the big takeaway that I want you to remember is you can convert your data into JSON and use SQLite to filter it. Whenever you go through a lot of data and you're writing your own dedicated filters to maintain stuff, this is a good way to do it. Here are the links to the packages that I used. So the JSON text, SQLite, both by Dr. James Powell. The JSON text object serialization by Pascal Neuperrier. Additional links are the YouTube recording from GDevCon #2, the blog forum post from Steve Watts, a tree control a little present. And if you're using SQLite and you want to secure it a bit more, there's an encrypted SQLite blog post from Steve Watts, encrypted SQLite, a gift, because he keeps on giving. He had a present, now it's a gift. These are SQLite tools that I almost daily use. So it's a validator, JSON path to find the correct path to an item, or the path finder, which will find you the path. With the JSON path, you can check stuff. DB browser or SQLite browser. Convenient tool to test your DB3 file or test some small queries. And a link to the JSON functions, the explanation of the functions that I showed you in LabVIEW, and they're explained for SQLite. So I want to express special thanks to Dr. James Powell, Steve Watts, and Pascal Neuperrier for their packages and sharing their knowledge, because without them, I couldn't have connected all their dots. But that's what got me there and helped me to create a generic user interface for my configurations. So that's it. A bit early, but. Are there any questions?
I believe I was told to not be loud enough by the keynote this morning. So have you started trying to use any of this tooling with PPL-backed classes or anything like that? Are you aware of anybody? No. So there's like the composition toolkit and uses some stuff that doesn't work with PPL, so I was curious.
I haven't used it with PPLs.
Okay.
I'm not using the PPL a lot anymore. I had a plugin system in my previous job, but now it's just applications built into an executable, no separate PPLs anymore.
Okay, thanks. Just curious if anybody else was.
So I'm not 100% sure, but doesn't gRPC, isn't there something that does the JSON to cluster thing like your tool does?
I'm not sure.
Maybe somebody else knows.
gRPC sounds pretty familiar
Because I think
to
there
the JSON
already
part.
is something that was created that does take, you know, the JSON to, to a cluster, but I'm not 100% sure. Maybe somebody else knows in the audience.
For that, the tool that I showed you to create the data type heavily relies on JKS serialization. It's just a small user interface around it. So the heavy lifting is done there. And I think maybe they have some of examples that already do that. I don't know, but I couldn't find it immediately and created a It's a JKI state machine, small example. It's just a user interface around a couple of steps.
So I have a question and a request.
Yeah.
So the question is, your JSON editor, you said that you were using a schema validation in JSON text in case they try to put a number in where there should be a string. Are you able to do that in real time with the operator so that they're blocked or get some sort of friendly reminder? Or do you do the validation after they've done the entry and they get a screw you jackass message, you didn't do it right? So I'm on your editor, I'm typing.
It's not while typing. They confirm, and then scheme validation is immediately.
Okay,
but
so
you have to finish your entry. Yeah.
Okay, but it's not some compile the whole. They have to do a validity check themselves of some kind.
It's a validity check. If I expect a number, or the scheme expects a number, and they put in A, B, C, D, enter, then it will say no.
Oh, okay, so it is automatic, but it's when they complete entry.
When they complete entry.
Okay, good. You don't want them because you don't want them entering something and then they get an error message.
What I did in the first version was checking by myself, like, is the entry a numeric or is it a Boolean, or otherwise string is okay probably. But then that scheme validation is pretty recent. And I think on the forum I also read somebody's working on a scheme generation, which would be even nicer. Because schemes are pretty hard to generate if you want good ones. If you want limits in there, or if you want all your data, if it's a big JSON structure, you're moving your heavy lifting to text-based JSON. But
right, because that's still a driver for a classic UI in that instance, is that we can do all the limits and a lot of stuff in place for that really easily.
That's one of the things, make it foolproof. Yeah. You need to limit your entries, because in production you don't want people to go out of boundary. But here, for me, that's my warning in the beginning, it works for me in a research environment. I know most of the time what I'm doing because I programmed the thing. So yeah, then this scheme validation is sufficient.
Okay, and then can you flip back through the packages that you use, slides, a little, so we can all get pictures?
Yeah. I will post it on the Discord, and the links are working.
So nice job. I mean, it's really neat to see the flow of the in and the out, and thank you for also sharing the packages and GIFs and such. One of the things that it was interesting is though that you're creating something that's seemingly, in terms of the display, like you said, you went to file, and then you're creating your interface within LabVIEW, and you're kind of working with that data set and manipulating it and displaying it, creating your own interface, seemingly that there might be other things out there. Now, it's really neat that we've got it in LabVIEW. We're using our own toolkits to make that happen. But did you investigate, I have no clue here, so it's not like really a loaded question, but where there's web-based interfaces that are probably already existing that give you 80% of what I did in terms of the taking data file and then giving that interface to it? Or was it, no, those things always fell short, and I really loved having that full customization basically down to the package layer? Did you, yeah?
No, no, I didn't investigate. I wanted a LabVIEW GUI for my configuration screen, but first, if I change something in the configuration screen, it stores to file. All the actors know we have to reload our configuration from file. But as you mentioned, what do you say? I find myself a lot of times just changing the JSON with some web tools or with even TextPath instead of using configuration screen. So yeah. There is this bypass, and probably there are other tools. But if it's inside, the advantage of the configuration screen is it's an actor. It sends a message, and the base actor sees like, oh yeah. So all the actors know configurations changed, reload configuration. So that's the advantage of having it in LabVIEW.
Okay. Awesome. And if I can do a follow-up, we got 2 minutes. Yeah, easy one. I missed the thing where what tool allowed you to do the serialization without going back all the way to making it a serialization class and doing the official, like to get all the data from the class out of it in a string format. I missed that part of it. And,
Get all the data in a
right, if you have an object,
Yep.
right, the actual serialization,
No,
right, that's a
two-
verboten.
It's two toolkits, actually.
So you can just say, is it any? You don't have to do any. You don't have to change the inheritance of it. It has some
No.
other hack way of getting to the private data.
No. No.
Right. No, I know that. I was missing the. I guess I'm looking for the
It's
under the hood mechanism that does it. I guess I've never seen that.
The under the hood mechanism, you should take a deeper look into this toolkit.
Okay.
You get a LabVIEW object, and what you get out here,
So, however, he did that underneath the hood there. That's the magic there. Okay.
yeah,
Okay.
but it's available. You can see it. Download that toolkit, and you can see how they did it. But you go from an object to an array of clusters, and each element is a level in your hierarchy with private data from your LabVIEW object.
Awesome. Thanks.
Are there any limitations at all on that in terms of supported object types or structures or anything like that? Or is it anything that you can put in a LabVIEW object works?
I haven't found any limitations. Even better, I can do empty clusters. Well, they turn out to be default clusters, but I can do empty elements. That was a bonus.
And then unrelated question largely, if you're saving things to both the JSON text files and then also the SQLite databases, when are you swapping back and forth between those two? And like, what's the official?
I'm not. I'm storing it in an SQLite database. So
Okay.
every measurement, every product that I measure is one entry in the database.
Okay, so the JSON text is just temporary to get it.
Storing also JSON text files for each measurement as a backup. If the
Okay.
database gets corrupt, I can restore it from my text files.
Gotcha, so the database is the master.
Because SQLite databases are file databases. They're not on the server, so yeah, I don't have a great backup mechanism there. It's just additional files.
Cool.
Okay, thanks.